In the previous video, we mentioned that the Poisson distribution is a special type of binomial distribution. We can use the Poisson distribution when the n, the sample size, is very large, and the p, the probability of a specific event, is very small. The probability of producing a defective screw is 1%. The question is, what is the probability that a lot of 100 screws will contain less than 3 defectives? We'll use the binomial approach first. What the question asks is the probability of having less than 3 defectives. So the probability of that is the probability of 0 defectives plus the probability of 1 defective plus the probability of 2 defectives. We learned from the previous video the probability of a specific event, x, in binomial distribution is the combination nx, then p to the power of x, q to the power of n minus x. To plug in the numbers, the probability of having 0 defects simply is n here is 100, x here is 0. The probability of having the defect is 1%, so it's 0.01. X is equal to 0. The probability of not having a defective is 99%, so it's 0.99. N minus x is 100 minus 0. For the probability of having 1 defective, n is equal to 100, x is equal to 1, then 1% of having defective to the power of 1, then 99% probability of not having defective, so 100 minus 1. Apply the same logic to the third case, having 2 defectives. Plug these numbers into a calculator. You'll get the probability of having 100 screws containing less than 3 defectives is 92.06. This is a rather long and tedious approach to solve this kind of problems. A much quicker way is to use the Poisson approach. The formula for the Poisson approach is the probability of having a specific event equals to mu to the power of x over x factorial e to the power of minus mu. Mu can be viewed as the mean of having a specific event. So mu is equal to n times p. In this example specifically, n is equal to 100 because we're looking at a lot of 100 screws and the p is 1%. That gives us 1. Similar to the previous approach, if we're looking at the probability of having less than 3 defectives, is equal to the probability of 0 defective plus the probability of 1 defective plus the probability of 2 defectives. Using the Poisson approach, mu is 1. X in the first case is 0 because we have 0 defectives over x, that's 0 factorial e to the power of minus 1 plus in the second case we have 1 defective, so mu is 1 to the power of 1 over 1 factorial e to the power of minus 1. In the third case we have 2 defectives, so mu is equal to 1, so 1 to the power of 2 over 2 factorial e to the power of minus 1. We have a common factor here, which is e to the power of minus 1. Then 1 to the power of 1 is 1. 0 factorial is also 1. Then 1 over 1 plus 1 over 2. This gives us the answer 91.97%. If we compare the results from the binomial approach and the Poisson approach, in the first case, the probability is 92.06%. In the second case, it's 91.97%. So these two values are very close, and the Poisson approach can be used as an approximation when in the binomial distribution n is very large, p is very small. In the next video, we'll do one more example on Poisson distribution. Assume n, the sample size, is infinity.